Good day, everyone. Welcome to That Friendly Writer Statistics and Data Analysis tutorial videos for TVL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll learn about the areas or regions under the normal curve. In this video, we will learn to give percentages of any region, whether below or above a z-score, between or outside two z-scores. The main focus of this video are the tails of the distribution. Alright, let's get started. This is called a normal or bell curve. Recall that z equals 0 refers to the actual mean at the center. So it divides the data evenly, 50% on the left and another 50% on its right. This tells us that the left and the right of a z-score, when you add them, always sums up to 100% or simply 1. This is an important concept, that the sum of all areas or probabilities in the normal curve is always 1. Let's explore every area. Case 1 is called below or left of z. You can easily get its area by using the standard normal table. Case 2 is called above or right of z. As the name implies, it is at its right. To get this area, just get the left of z and subtract it from 1. Case 3 is between z1 and z2, which I think is obvious why it is called between. To get this area, use the z table on both given values. Then we subtract the bigger area by the smaller area. Case 4 is the area outside z1 and z2. As you can see, it is the reverse figure of case 3. So we just do case 3, then subtract the answer from 1. So this summarizes how to get the areas of every region: left or right of a z-score, between and outside of two z-scores. Let's go for some examples. We will use the standard score z equals negative 1.96 and give every region associated with it. First, let us give the probability below z equals negative 1.96. This is also called as the left of negative 1.96. To get this, just use the standard normal table. The percentile 0.025 is its area. We will also call this as the left tail. Why a tail? Because it is attached at the far end of the distribution. In this case, it is attached at the leftmost part. So this is called a left tail. But what if we need to get the area above z equals negative 1.96? This region is at the right of 1.96. So our answer from earlier, we just subtract it from 1. You may use the assistance of your calculator for accuracy of computation. In this case, 1 minus 0.025 equals 0.975. This is the answer. Do you think this is a tail? The answer is, it is attached at the very right of the distribution, but I don't agree that this is a tail. Why not? Because the area is too large. To me, I would only classify it as a tail if the area is only 0.10 or less. This will be discussed in future lessons. What if we have two z-scores, negative 1.96 and positive 1.96? What if we need to get the area between them? First, we just use the standard normal tables on both of them. Then, we subtract the bigger minus the smaller. Your calculator will help you give more accurate answers. Therefore, the answer is 0.95 or 95%. Lastly, how about the area between or outside these two values, negative 1.96 and positive 1.96? Since our answer a while ago was 0.95 or 95%, we can just subtract this from 1. So, 1 minus 0.9500 equals 0.05 or 5%. The total area of these outside regions is 5%. Now, let us see if they are tails. Are these attached to the far ends of the distribution? Yes, at the far left and at the far right. Are these areas small? Yes. Therefore, we consider them as tails. In fact, we will call this illustration as two tails. So that means the area of these two tails is 5%. And this also means that when we divide the area by 2, the left and the right tails are both 2.5% each. In summary, about negative and positive 1.96, to get the left side, just use the table. To get the right side, subtract the left side area by 1. To get the area between two z-scores, use the standard normal table on both of them and then subtract them. To get the area outside two z-scores, get the area between them and subtract from 1. You can get the area of either tail by dividing by 2. This only works if we have the same z-score. When do we say an area is a tail? If it is attached at the far end, whether left or right, and we should have a small area. There we go, the areas under the normal curve. Here is your practice task. Use the z-scores negative 1.65 and positive 1.65. Sketch the illustrations first, then give the areas. Left of z equals negative 1.65, right of z equals positive 1.65, between these two scores, and outside these two scores. Also, which among your answers are considered tails? Alright, this concludes our video for today. Hope you learned something new. Have a friendly day!